Hi everyone. This session is recorded in the context of the Azure Back to School initiative. And first of all, I want to thank our sponsor, Captain Hyperscaler and Tracetree, to make this event happen. I'm Massimo Crippa, lead architect at Codit, and in this session we will look at the Azure API management generative AI capabilities, a set of features designed specifically for generative AI use cases. Now, it is evident to everyone that generative AI has opened up a wide range of applications. Applications that can enhance business operation, but in general also change the life of everyone. So everyone is well aware and proficient with OpenAI and ChatGPT. So common use cases are, for example, generating, as we were saying, that personalized content, but also creating, for example, instant chatbot capable of handling complex questions about our own personal data. On the other hand, we have this democratization of large language model, especially through the model as a service offering that Azure and Microsoft has. And the fact that we have access to a lot of these different models that can manage a lot of sensitive data, that brings several challenges, including challenges about cost, challenges about security, data privacy, governance, and so on. So, and this, the interest on these models and the type of content that can be generated via these models is it's something that is really very relevant for every industry that are embracing those AI new features. But if you think, for example, at regulated scenarios like regulated industry like financial services, healthcare, and government, those industries in particular, they are facing unique challenges in ensuring the secure access, but also the responsible consumption of these models. When we look at the way that our application, our intelligent application, access to the result produced by those models, the good things that is done via, most of the time, web APIs, and that makes the integration simple and standardized. So the question is, so we talk about challenges and challenges in control of the access and the result of these models. So the question is how we can accelerate our access to this technology, but at the same time, so we want to make it secure and responsible. How can we understand how to use those models and how to prevent the misuse? Now, the answer is to delegate those challenges like governance, security, observability, all of those cross-cutting concern of the AI applications to a central AI gateway, in this case, an AI gateway powered by Azure API Management. So that gateway that sits in front of the large language model, that gateway allows an effective, a uniform, and observable access on to those services. So the developer from one side, the developers of intelligent app that they want to integrate with what we have on the right, those AI services, they will be able to be more productive and they will be able to ship capability faster because they will have a standardized way to integrate, not ad hoc, depending on the model that you have on the right. And also for solution architects, they will have a platform that ensures visibility, a platform that ensures governance, control, compliance, as we were saying. So they can connect on a single point and keep this under control. And then, because it's built on top of Azure API management, this can be in the cloud, or also can be close to the self-hosted LLM to achieve the best scenario, architecture, and performance and low latency, depending on your requirement. Now, so what are the objectives of this AI gateway? So we already mentioned some of them. So is to do more with less, so to innovate faster, so accelerate the AI experimentation, make sure that we ensure visibility, compliance, governance, having a view also on the cost, so prevent the misuse of those models. And then the last one is to operate with confidence, so to give confident deployment and also give to developers a sort of blueprint to experiment and then go to production with AI integration and AI models. Now, let's look the capabilities of the generative AI capabilities of Azure API management. And the best way to do this, I believe, is using this AI gateway repository, those examples that have been built by the Azure Global Black Belt team. So all the credits to this team. They did a great job. We'll explore in 1 second that repository. Okay, let me bring the browser in. If we go with this, if you follow this URL, aka.msai gateway here on top, we will be able to access to the repo, the labs created by the Azure Global Black Belt team. And you can see here there are some news in the repo, an explanation of the generative AI concept, and all the labs that has been developed to explore these capabilities. We'll go back very soon to this, in a minute, to this repo. Okay, how do we approach the exploration of these AI capabilities? In this session, using 3 steps, we will go through the security, availability, and observability. Now, a few words. So by putting a gateway between our intelligent applications and our AI endpoint, we can have specialized security policies. So, for example, we can use decouple the security scheme of our OpenAI service from the way the security scheme of our gateway. So the way that we want to authorize the calls that are coming from our application to the API management. So we will have a sort of security brokering. Another example is using OAuth to have a fine-grained access. So go the next step of deciding who can access to what. We can use key validation, we can implement schema, data validation, prompt validation, threat detection, etc., etc. So all because we are in the middle, all because we can see the traffic that is passing through. This allow through the gateway. This allow us also to have a positive security model, not only understand later if there were misuse, but explicitly define what is allowed, so prevent the misuse at the beginning, not in a detection mode. And another example is traffic control. I can implement rate limits, I can implement quotas, so I can make sure that the AI services are used in the way that I want. So I don't consume, for example, all the tokens that I might have available. So I can, let's say, one application has access to a certain quota, another application has access to another amount of tokens that are available to my enterprise. Now let's look some example of labs that are in this AI gateway. One is the request forwarding. As I was saying a few seconds ago, is a lab that allow us to explore the coupling of a security scheme broker, where I have on the right the OpenAI service that is secured using RBAC, and is accessed by API management using a managed entity, and my application that sends the request to API management, it can authenticate and control the usage using a subscription key. That will help us to not expose the security of OpenAI to the consumer, and to use API management as a central point and a sort of a keyless approach, because the keys of OpenAI stays secure in our backend. That's also a super easy and the first step to explore an OpenAI service into Azure, because it's extremely simple. It has no impact on the application. The same messages, there is no message transformation whatsoever. So the requests that are coming in are propagated towards the OpenAI service. Another example of security is rate limiting. Not only rate limiting in terms of request, but also rate limiting to enforce the token usage in a real time. So you can define token limit, and if you can go over the token limit, for example, for a specific user, that user is blocked. Also for this policy, it's no changes because it's security policy. There is no changes on the application, because it doesn't touch the message that is flying through. It's just a security enforcement. Another important things in the context of generative AI is prompt guarding. So I want to make sure that my prompt doesn't contain hateful or violent wording, and I can use in this, here you can see on the top, the content safety API to make sure that I forward to OpenAI only something that doesn't contain that kind of language that is not allowed. So actually, this content safety API, it just block what is the request. I will return a code in the context in the range of the 400. Here I also put a print screen of a very simple prompt guarding, so that you can build with your by leveraging the out of the box policy capabilities of API management. It's just an example to say, okay, it's not that you have to use if you need any specific prompt guarding that is related to your business, you can just try to do something similar or more, more complex for real use cases to block the content and not get this prompt reach the OpenAI service. Now let's go in practical, and let's look an example of request forwarding in our Visual Studio Code. Okay, I open the GitHub repo here in my VS Code, and I can go and on this folder, request forwarding, and I open this request forwarding Jupyter notebook file. Even if you are not familiar with Python and Jupyter notebook, I can assure you this approach is extremely simple. You can see here there are the prerequisites that you need to follow to start using this kind of lab approach. You need Python, Visual Studio Code with the Jupyter extension, you need an Azure CLI, an Azure subscription, and make sure that you sign in to your subscription using the CLI before running the run book. And here it's really a step-by-step approach, very easy and to use, and also easy to understand. It starts with an initialization of variables that you can fine-tune to change the resource group name if you want, to change the location where you want to deploy your resources, and so on. You notice here there is also the possibility to mock an OpenAI service, so you don't need to test some labs. You really don't need a real OpenAI service on Azure. You can use a mock service, especially for some circuit breaking tests and so on. But in this case, to show for this session, I will use a real OpenAI service on Azure. So I can, if I want, run one by one the steps, or like in this case, I initialize my variable. I can see here the output of my cell, or if I want, click on the run all. Let's see what happens when I click on run all. So I will, the engine will run, will initialize my notebook. In this case, it creates an Azure resource group. Will then proceed in creating an Azure OpenAI resource, in this case by running NZ CLI command. It will deploy my OpenAI model. Then we'll create an OpenAPI management instance. It will fetch some details for my OpenAI instance, like the URL, but also the subscription key. Why this is important? Because in this scenario, the subscription key, it will be used to authenticate the request, to authorize, let's say, the request that I'm sending from my application to API management, and then they will be forwarded to OpenAI using authenticating using a managed identity. Then once we fetch these details, there will be the runbook, the notebook, sorry. It will create, it will assign to the managed identity of Azure API management the role cognitive service OpenAI users on the OpenAPI, on the OpenAI resource. Next steps will be taking the OpenAPI of the OpenAI service and run it and load it into API management. That's what it is happening here. Next step is to create the policy that will inject the managed identity token into the call towards the OpenAI service. And then, as a last steps, just do a call. And you can see here the call succeeded with 200. The subscription key is passed. I can run it again, and I can see what happened. So with this very quickly and easy to deploy notebook, I just have an end-to-end running scenario. If I go on my Azure, here we are, request forwarding. I do have my API management provision, the OpenAI service. I can go, let's do one step back. I can go in the OpenAI service, go on access control, go on role assignment, and see the managed identity has been added with the cognitive OpenAI user role. That's how I authorize the call. And here, how do I inject this security header is by adding this policy here on top, where I get the token for my by Azure API management instance, and then I add the token in the authorization header. And that's how it works, simple as it is. And this OpenAI API with this sticks operation is created by importing just an OpenAPI specification file, also known as Swagger. Simple as it is. So I wanted to show this, how can easily you can start exploring this security scenario by using this repository and this extremely simple lab done with Jupyter Notebook. Okay. Let's also quickly look at the content filtering. Here I have the notebook. I already ran it before, so let me initialize the notebook variables. I don't need to create the resource group. The bicep deployment has already been triggered, but I need to read the result of my bicep deployment to fill some variables like the gateway URL, subscription keys. So here is done. This deployment also, this bicep also deploy the content safety API. Let's see if it works fine before proceeding. Yes. And then I can test my end-to-end scenario to call the OpenAI API hosted in API management. If I'm saying, okay, you are a sarcastic assistant and can tell you something about to hurt myself, that kind of request will be blocked by the content safety API. Let's see it in action. I just run this and then I get the 400 because the request is blocked at API management. We can go to see on content filtering what has been deployed on API management. So these are the resources. There is our API management instance, the content safety API. Let's see how this request is, this protection is implemented from a policy point of view. We go here, and that's actually what happened. So we have a request that is sent to our safety APIs, and then depending on the response, we can let the data flowing through the model or returning an error, a 400 as we saw. So in that case, if I go back to my tell me something, if I can change my prompt by saying, tell me, can you tell me something nice? This, I suppose, it will work fine, and I will not have a 400 as before. Okay, that's these were the two examples I want to show to you about security. But if you go to the aka.ms/AI gateway, you can find more example and labs on how to secure your OpenAI service. Let's now move on with a second set of labs, and it's all about load balancing. Here you are. So load balancing for intelligent apps. What does it mean? You might have multiple OpenAI instances deployed in your enterprise. Some OpenAI instances might be, let's say, serverless, so you consumption-based. Some OpenAI might be leveraging the pre-allocated throughput unit, so PTU. So, and you might want, for example, to first consume your PTUs, your capacity that you pre-provisioned, and then when these units are consumed, fall back on these, let's say, serverless instances. You might also want to keep the traffic in one region, and then if needed, go to the other region. Another type of intelligent load balancing. So this is what the API management allows you to have. So to have a group of endpoints, create prioritization, create round robin, and make sure that you can distribute those requests in an intelligent way. Because you have multiple OpenAI endpoints or large language model endpoints, you have multiple URL, but that's not good for consumption, and it's not good for your application. That's why API management allows to have you centralize traffic management, so a single endpoint where you can route all of your, let's say, AI traffic. And of course, that at the end of the day makes developers happy, and it makes everything simple and uniform. By having this intelligent load balancer, you can also have a failover and resilience. If one backend is not available or is consumed or something is wrong, you can fall back to the other one in a easy and intelligent way. Overall, at the end of the day, this improve your application reliability. Another use case is A/B testing. So imagine that you're using the 3.5 GPT and you want to move the 4.0 or you can transition from one model to the other in a transparent way by using an intelligent load balancer. Let's now see some examples that are in the repositories. One is a load balancing based on backend pool. The backend pool is an object that has been recently released in API management some months ago, where you can group backends that are native objects into a pool. So when those backends belongs to backend pool, you can then load balance the traffic between those pools by assigning as well, let's say, priority and weight. Priority groups a set of backends. So if I put 3 backends, 4 backends in priority 1, so they belong to the same group. And then within this group, you can use weight to also have a second level of traffic splitting. As you can see here in the picture, in this animated picture, if something goes wrong on one backend, is not anymore available, everything goes to the other one. So you can, in this way, as we were saying, improve availability. In this case, actually, is a configuration on API management, and that things avoid any configuration, any changes in your application, because also this is 100% transparent. Another feature to, let's say, to have an intelligent load balancing and increase reliability and availability of an application is using a circuit breaker, another feature of API management. So if, and this in combination with the load balance, the backend pool makes the load balancing intelligent. So if the downstream service is not available, he will make sure that the request will not be forwarded. By configuring the circuit breaker, you can define the rules that at the end of the day decide whether is available or not. You might consider a 429 a status code that result in a circuit breaker, yes or no, and other kind of parameterization. This is very important and interesting for, as I was saying, availability and reliability. There is another example in the repo, is an advanced load balancing things. Is not based on the backend pool, but is based completely on policy. We might go through this quickly in our demo. So let's not wait more time. Let's jump in Visual Studio Code. Okay, we saw last demo was about content filtering. Let's now move to backend pool. Okay, it's here, same story. I already ran it before, so to run it again, I will not run the full notebook. I will load my variables. I will get some information about the deployment. In this case, let me go to resource groups, backend pool load balancing. You see that we have 3 OpenAI instances, one in UK South, Sweden Central, and France Central, and our API management configured with backend pool. Now, one step back, here you can see the configuration. All the 3 endpoints belong to the priority 1, and within the priority 1, 80% of weight, 80 goes on 80% of the traffic goes on UK South, 10% on Sweden Central, and 10% in France Central. Now, I load this, sorry, my details, and now I'm ready to run 20 calls to this a single endpoint API management, and these 20 calls they will be load balanced through this the 3 OpenAI instances, and let's see it in working. So it goes France Central, UK South, Sweden Central, France Central, Sweden Central, etc., etc. So let's see the next ones. Oh, let's wait a little bit more. And then when we reach our 20 calls, we will be able, thanks to this Python libraries, analyze the result and have a nice representation of the usage of our load balancer. And yeah, it was fast. So we can see here that it went 1, 2, 3, so 4, 5, 6 time on UK South, and then France Central, and then Sweden. Actually, should go more on Sweden because the priority is 80. But okay, that's allows you to explore and try again the setup and understand really the usage. It might be that when I code the first time, there were a temporary unavailability on Sweden, and then that's why it was mainly load balanced in this scenario. So this is a way to easily test and gain an understanding this feature, how this feature translate from an API management point of view, not via policy in this case, but just creating the backend pool and assigning those backends into the backend pool, and by leveraging the bicep file or whatever tool you want to use, define the weight and the priority. So this is for the load balancer. So I also deploy here, I suppose, the advanced load balancer or not. No, is not deployed. So we can move on. Let's move on with the next steps on our presentation, which is the observability part. By having a central gateway, the central gateway allow us to have visibility on whatever is passing through that gateway, the traffic, the API calls. We can understand how the service is used. We can understand performance. We can understand if the service is available, if the service is held. We can how many tokens has been used, what is the cost. We can divide the cost and so on. So by having all of this data, we can also debug and troubleshoot our application, understand the sequence of the call, having an end-to-end visibility of our AI application. And that is done leveraging the built-in logging of API management that use the concept of logger, and this logger transmit data into the Azure Monitor family, leveraging log analytics, application insights, and so on. So there are two kind of flow of monitoring data from API management to Azure Monitor, but also there are metrics and information emitted by the OpenAI service. And also this example provide, the built-in logging example provide notebook to understand the usage of your AI application. Another example is this vector search or the RAG pattern lab. So the first time I was approaching to generative AI, I was wondering, okay, how this RAG pattern works. I was looking for a nice example to understand, explore, and play. And this lab, this repo contains a lab that is super easy. Again, because of that notebook approach, one click and bam, you are up and running and you can understand. And because we proxy through API management, the AI search API, but also the embedding APIs and the chat APIs of OpenAI, we can see end-to-end what is happening in our application and better understand what kind of messages are exchanged in our AI application. Another generative AI capabilities is like the capabilities of the possibility of emitting metrics from our API management service. API metrics like that includes token, but these metrics can also be multi-dimensional and adding the dimension that we prefer. So we can define our custom dimension and then having that matrix that is split by that dimension. So you can align our reports with our business needs. As a last step, let's go back again to Visual Studio Code and explore a little bit this vector search scenario. So let's see how it works. I initialize the notebook with all the details. I don't go through this. The resource group I already created, deployment already triggered. As usual, I run my, I just go and read the result of the deployments. The AI search index and movies, I should be already okay. Let's see if I can run this search. It's about what are the best movies about superheroes. That's my request. But here I have my RAG application that leverages LangChain. As I was saying before, we will use OpenAI embeddings to calculate the embeddings, the OpenAI chat for process the result of our vector store, and Azure as vector store. So, but I know nothing, let's say, about this. I just run it. But how can I understand this kind of application if I know nothing about a Python and the interaction between this service? I mean, a result, okay, it looks good, but okay, it might say nothing to me. Here, from observability point of view, I have this request ID that I copy. Let me do this. And then I go on my Azure, where I have my vector search. I go on application insights that has been connected to API management, and I can go in my transaction search. And then I put here, let's say, last 4 hours, and I put here my request. Now the data is not yet processed by application insights, so it's coming. Let's take another one, someone that has been done some hours ago. I click on any request. So, or in this case, let me go to the initial one. Here we are. So I can see here that all the calls correlated together. I can see, let me go here, that first the embeddings are called, and those embeddings are called on the API management. Then the same request forward to the API of OpenAI. I can see the request and the response. So the input for my ADA embedding and the answer. Then these embeddings are used to call our Azure search via API management. I can go again here, see the request body and the response body, what it returns from our vector store. And finally, the call, the prompt that we are sending to API, to Azure service. In this case, that's what we are sending, and then we can get the full response. In this way, by leveraging API management and the logging capability, we have, as you can see, the end-to-end visibility, request, response, all details of the calls and the performance. That is very useful to understand the usage of our AI resources, our AI API. Let's get back to our Visual Studio Code and explore 1 second the built-in logging, and let's run it all as is. Why we're doing this? Just to explore one interesting things that it comes with this repository. That this demo will take a little bit more because I ran it for the first time, but I will just cut and edit this video to go quick to the result. Why I want to show you this? Mainly because this comes with an interesting notebook. Let's see what is the result of this deployment. Okay, the deployment is completed. Here we can test, just run some tests some calls to check the labs. But what I wanted to show to you is the result here. So let's get back to Azure and let's refresh. And I got this built-in logging. And what is nice is also this Azure workbook that is coming with this example. I need to run it some more data. Let's do it. Okay, let's run it more. Let's see. Let's open the workbook. And here we are. So we can see the usage of our so the calls that has been triggered, token count, and other additional details. This is an example. You can take this and extend it as much as you want to make your observability, your application more observable. Okay, nice. Brings back to the end of this session. So we saw how the generative AI pattern is key to optimize the access to these AI services by having Azure API management in the middle to ensure the secure access, a uniform access, and also an efficient utilization, which leads to high available and reliable applications. We also saw the gateway repository created by the great Azure global black belt team. That repository has a lot of experiment. He has a lot of labs. You can use this experiment to find your way and to facilitate your way with AI and facilitate your production, your road production. This repository contains Jupyter notebooks, Python code, Bicep, Azure CLI. It makes everything together. It makes it easy. And what I wanted to say, yes, straightforward to consume. There is a backlog of experiment, so the repo is every weekly update, monthly updates. There are new labs coming in. Labs getting updated is very, very, very interesting and maintained by the Microsoft colleagues. That's I believe that this is very interesting and very powerful. I hope that this session was interesting. I want to thank you for watching this episode and wish you a nice rest of the day. Bye.